Hello, dear students. Today we are going to discuss the triangle and its properties. Now, before I proceed further, I just want to get a confirmation from couple of you that you are able to hear my voice very clearly and able to view the screen properly. Uh,
Yes, sir.
Yes, sir. We are
Your voice
okay.
is clear.
all right, all right, all right. Couple of confirmation is sufficient. Thank you. Now, let us first understand, what is a triangle. Okay, I hope many of you seen a triangle. It is a simple closed curve made of three line segments. Okay, so let me show you one such. So I am going to show you now. If you see, dear students, that adjoining diagram, you see there are three line segments. What are the line segments? One is AB, another one is second one is BC, and the third one is CA. These are the three line segment. One is AB, one is BC, and one is CA. So as I was telling that ABC is a triangle as it is a simple closed curve made of three line segments AB, BC, and CA respectively. Now, this triangle has three vertices. What are the three vertices? That A is a vertex, B is a vertex, and C is a vertex. So these three are the vertices of the triangle. And this triangle has three sides, as I just informed. The sides are AB, BC, and CA. And and the triangle is also having three angles. The first angle is BAC. This is one angle. Second one is that ABC. This is another angle. And the third one is BCA. This is another angle. So, dear students, whatever we have discussed now, that in this triangle ABC, we see there are three sides AB, BC, and CA, three angles, as you see that the angles are BAC, ABC, and BCA, and it has three vertices A, B, and C. Correct? Now, if you see the line segment that is AB, BC, and CA, so there is a bar is given on top of it, just to make sure it is a straight line segment. Okay. For discussion, if you see somewhere that it is written that PQ and there is a curved one, that means you can assume it is a curved one. So this point is P and this point is Q. Just as a side discussion, no relation with triangle, I'm just informing. And if you see a straight line, for example, the straight line is given as RS, then it is generally mentioned as simple RS or there is straight line bar. If nothing is mentioned, then you can assume it is a straight line segment. If specifically this is mentioned, that is on top of PQ, you can assume it is a curved one. So far we understood that a triangle is a simple closed curve made of three line segments. It has three sides, three angles, and three vertices. Now, if you observe once more, the side opposite to the vertex A is BC. Okay, as you see, if I use a different color, the side opposite to the vertex A, if we take this vertex A, that opposite to the vertex A is the side BC. Similarly, that the side opposite to the vertex B is CA. and the side opposite to the vertex C is AB. Clear? Now, we can classify triangles based on two things. One is based on sides and based on angles. Okay? So let us understand this thing in more detail. That classification of triangles based on sides and based on angles. So I'm just going to write it here. Classification of triangles. As I was saying, that we can classify triangles based on sides and we can classify triangles based on angles. And how this classification is happening, let me show you. Now, when we classify triangles based on sides, then we name it in different way. What are the different names we give? Let me show it to you, dear students. That based on sides, when we classify triangles, we give the name as scalene triangle, isosceles triangle, and equilateral triangle. We will come to all these things in details. That I repeat once more. When we classify triangles based on sides, we classify it as a scalene triangles or isosceles triangles or equilateral triangles. Now, what is a scalene triangle? Scalene triangle is a triangle in which all the three line segments or all the three sides of a triangle are of different length. That means what, dear students? That if we have one side like this, one side like this, another side is like this, and it all are different. That means if we say that ABC is a triangle in which AB is not equal to BC is not equal to CA, then we can say it is a scalene triangle. So what we can say, this is a scalene triangle. Correct? Now what is isosceles triangle? Isosceles triangle are those triangles in which the two sides of the triangle are of equal length. The triangle has three sides. Out of those three sides, that two sides has to be equal in length. Then we can say it is an isosceles triangle. So let us look one isosceles triangle. One isosceles triangle could be something like this. Whatever the triangle I am drawing, it is not up to the scale. Okay. It is approximately I am drawing. So if this is the vertex A, this is the vertex B, this is the vertex C. So when we write AB equal to AC and BC is neither equal to AB nor equal to CA. That means what? AB is equal to AB is equal to CA and that is not equal to BC. Then this kind of triangles, we can say it is isosceles triangle. So I repeat once more. A triangle has three sides. Out of these three sides, if we find that two sides are having equal length and the third side is different length than the other two sides, then this triangle is known as isosceles triangle. As you see in the blue color I have drawn, that in this triangle ABC, we see that AB is equal to CA, but both these are not equal to BC, or other way I can say BC is not equal to AB And obviously then BC is not equal to CA, but AB is equal to CA. Then we can say such type of triangles as isosceles triangle. And the third type of triangle is known as the equilateral triangle. So we are done with isosceles triangle. Now we are going to discuss about equilateral triangle, dear students. What is equilateral triangle? Equilateral triangle, such triangles in which all the three sides are of equal length. That means if we get a triangle something like this, again these sides lengths are not to the scale. So if we consider this is a triangle, as I am writing in the green color, AB is equal to BC is equal to CA. So what we can say is that AB is equal to BC is equal to CA, and such triangles are known as equilateral triangle. Equilateral triangle, correct? Now, as I said, that based on sides, these are the classification of triangles. That is scalene triangle, isosceles triangle, and equilateral triangle. Now, dear students, let us understand the classification of triangles based on the angles. That is acute angled, obtuse angled, and right angled. So let us understand. What is acute angle triangle? Dear students, that acute angle triangles are such triangles in which all the three angles are acute angles. That means they each one of these triangles are less than 90 degrees. So let me draw one such triangle. Okay. If you see this triangle, that in which the angle A, angle B, and angle C, as you see, these three are, each of these angles are less than 90 degrees. Then these type of triangles are known as, uh, at acute angle triangle. I repeat once more, dear students. Acute angle triangles are such type of triangles where all the angles in the triangles measure are less than 90 degree. So what we can say? We can say that angle A is less than 90 degree. Angle B is less than 90 degree. Angle C is less than 90 degree. So that is known as acute angle triangle. Okay, so I hope I get a question. So let me look into the question and let me answer accordingly. Yes, we will discuss. Let the time come. We will discuss about the hypotenuse. So now the second one, what I'm going to discuss, dear students, is the obtuse angle triangle. So what is obtuse angle triangle, dear students, is that obtuse angle triangles are such triangles in which one of the three angles is more than 90 degrees. Means there are three angles of a triangle as we discussed few minutes back. Out of those three triangles, out of those three angles, one angle has to be more than 90 degree, and such triangles we call as obtuse angle triangle. Now, so what is this? So if I show you one such triangle, it is something like this. So let me draw it in a different color. Let me draw it in a green color. So if we consider this triangle B and C, so you see, dear student, that this angle B is greater than 90 degree. Okay. So we can say this triangle is obtuse angle triangle, obtuse angle. Okay. Now the next one is that, so first one what we discussed, dear students, first one we discussed about the acute angled. Then we discussed about the obtuse angled. Now what we are going to discuss, dear students, is that right angle triangles. So dear students, the right angle triangles are those triangles in which one of the three angles is measuring exactly 90 degrees. As you know, the triangle has three angles. Out of those three angles, one angle is measuring exactly 90 degrees. Then we can say that triangle as a right angle triangle. So if I show you that, if I draw one such, so it will be something like this. Let me draw in the green color. So this angle, generally we denote the right angle something like this. So this angle is exactly equal to 90 degree. The angle B is exactly equal to 90 degree, and we can say this is a right angle triangle. A right angle triangle. So I hope you got a very clear idea. Now, dear students, let me tell you an interesting statement. For any triangle, whether it is a scalene triangle or isosceles triangle or equilateral triangle or acute angle triangle or obtuse angle triangle or a right angle triangle, okay, the sum of the three angles of the triangle is 180 degrees. I repeat once more, dear students, that sum of the three angles of any triangle is equal to 180 degrees. So let me write it down. The sum of the three angles of any triangle is equal to 180 degrees. Now, interesting thing is that, so if we consider about the obtuse angle triangle, so how many angles can be obtuse in an obtuse angle triangle? Only one, because this has to be more than 90 degree. So it is not possible to have two angles of a triangle more than 90 degree. Then the sum of the three angles will be more than 180, which is not possible. So that is why it is in an obtuse angle triangle, it is possible to have exactly one angle which is obtuse, that is more than 90 degrees. In the similar manner, that in a right angle triangle, it is not possible to have two different angles is exactly equal to 90 degrees. Then the third angle will have some measure. Na? In that case, the sum of the three angles will be more than 180 degree, which is not possible. As we just learned, the sum of the three angles of any triangle is equal to 180 degrees. So, what is the conclusion we are making? For an obtuse angle triangle, exactly one angle of the triangle can be obtuse. For a right angle triangle, exactly one angle can be right angle. But in case of acute angle triangles, you see, as you see that all the three angles are less than 90 degrees. It's possible to have all the three angles are acute. We can have different kind of combinations of acute angles to sum up them to 180 degrees. For example, we can have a acute angle triangle with having one angle 45 degree, one angle 60 degree, one angle 75 degree. 45, 60, 45, 60, 75 degree. So what I am saying that one angle can be 45 degree. Sorry, let me use that different color. One angle is 45 degree, another angle is 60 degree, another angle is 75 degree. Okay. So the point is that what I'm saying is that if you add these three angles, it has to be 180. And another combination it could be, so I can have another combination like that. It can be 50 degree. It can be, the second one can be 55 degree. Third one can be 75 degree. So in that way, different combination possible to construct acute angle triangle. Okay. So now let us discuss another important point that is called the median of a triangle. So what I'm going to discuss now, dear students, is the medians of a triangle. So what is medians? So let us understand. So dear students, so let us consider any triangle. Okay. Means it doesn't matter that it is a scalene triangle or isosceles triangle or equilateral triangle or acute angle triangle or obtuse angle triangle or right angle triangle. You consider any triangle. So let me take one such triangle, something like this. Okay, just concentrate on the triangle part. Okay, that ABC is a triangle, what we have considered here. Now, dear students, let us consider the side BC and let us find that midpoint of the side BC. That means we are finding a midpoint of the side BC. You know from your existing knowledge that if I give you a line segment, how to find the midpoint of that line segment. Using that concept, you can find the midpoint of that line segment BC, and we call that line segment as D. Correct?
Can you explain this again?
Yes, definitely. So what I'm saying is that let us take a triangle ABC and let us consider the side BC. Only side BC we are considering. After considering the side BC, we are taking the midpoint of that line segment BC. So let us consider this is the midpoint which is marked as the point D. So now as D is the midpoint of BC, obviously BD has to be equal to DC, correct or not? That BD has to be equal to DC. And what I was telling, another point is that you know that how to find the midpoint of a line segment. If anyone is having any doubt on how to find the midpoint of a line segment, we can have a separate discussion. But let us now continue with that how to find the medians. Now, once we found that midpoint of the line segment, then what we are going to do? From the vertex A, we draw a line segment to D. That means what it will looks like? It will looks like something like this. So what you see, dear students, is that in the previous step, we already found that midpoint D. Now what we have done, that from the vertex A, we join that line segment D. Then we can call this AD as the median. AD is median. Okay. Now, when we are joining a line segment from a vertex, the line segment should intersect the opposite vertex, opposite side. In this case, when you are joining the line segment from the vertex A, obviously it should come and it should intersect that opposite side, that is BC. And where it will intersect? It will intersect at the midpoint of that line segment BC. Then we can say AD is a median. AD is a median of whom? AD is a median from the vertex A to the side BC. In the similar manner, okay, what we can construct is that we can construct, okay, the median for the angle, for the vertex B. And how we can do this thing? In the similar manner, that when we are going to construct the median from the vertex B, first we find the midpoint in the line segment CA. Suppose this is the midpoint of the line segment CA. Then what we will do after that? After that, we will join that B and that midpoint. For example, if we tell that midpoint of CA as E, then we are joining B and E. So we can say? B is also a median. B a median. In the similar manner, if we need to find the median from the vertex C, what we will do, dear students? In the similar manner, first we will find the midpoint of the line segment AB. Suppose this is the midpoint of the line segment AB and we name it as F. Then what we will do? Now we will join from the vertex C to the point F, which is the midpoint of the line segment, AB. Then what we say, dear students, that CF is median. So in a triangle, there are three medians. That's why it is a plural number, that medians of a triangle. There are three medians corresponding to each of these three vertices. Interestingly, you will notice one thing, dear students, is that all three medians also intersect at a point. And what is this point? That we will discuss later. So that is not the point of discussion here. That we will discuss later. Let us first understand the basic, terminologies like the medians of a triangle. Now, dear students, what I am going to discuss is the altitude of a triangle. Okay, so let us discuss the altitudes of a triangle. If anyone is having any smallest query, never hesitate to ask me. Okay. So,
sir, I had asked a doubt long ago in the chat.
Okay, so let me look at it. Okay, just a minute. Thanks for asking. Let me have a look at it and then let me answer you accordingly. Sir, isn't it a right angle triangle A plus B equal to C? Not necessarily. Okay. Let me discuss this question. So Ronak has raised a very good question. Whether in a right angle triangle, whether that A plus B is equal to C, that is correct. Yes, obviously. Why? But A should not be in this case, angle A and angle C, yes, that has to be equal to 90 degree, and B is 90 degree. But it is not necessarily mean that A has to be equal to C. So what is this? If I answer your question, angle A plus angle B plus angle C is equal to 180 degree.
Yes, sir. Thank you, sir.
Okay. So that implies what? As angle B is equal to 90 degree, so this is 90 degree. That means angle A plus angle C is equal to, let me write clearly, angle A plus angle C is equal to 180 degree minus 90 degree. That means angle A plus angle C is equal to 90 degree, which is equal to angle B. But I repeat once more, that doesn't mean that angle A and angle C has to be same. It can be different also. For example, we can consider angle A as 30 degree, angle B as 60 degree. We can consider angle A as 20 degree, angle C as 70 degree. And it is possible to have equal also, when we can have angle A as 45 degree and angle C also 45 degree, but they no need to be necessarily always equal. Okay, so as I'm able to answer your question, now let me proceed further with the
Yes, sir. Thank you, sir.
thanks, altitude of a triangle. Okay. Now let us consider a triangle. Okay. Okay. So let us consider a triangle, something like this. So let me draw this triangle. So this is A, this is B, and this is C. These are the three vertices. Now, dear students, from the point A, before I am going to discuss about the altitude of a triangle, let me give you a very fundamental, understanding of the distance of a point to a straight line. So let me use a different color. So let us consider this is a line segment, and let us consider this is a point. So suppose this is the point P and this is the line segment, suppose LM. Now listen very carefully. From the point P to the line segment LM, okay, how many lines I can join from the point P to the line segment LM? Many. What are those many? So let me show you. So it could be one line segment could be like this, one 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 could be like this. Like this, there are many lines I can join. But we should consider only that line out of all these lines. As you see, if I name them as, suppose this is P1, this is P2, this is P3, this is P4, this is P5. What is the distance among all these lines? Only we'll consider that line segment which is the minimum in length. That means PP3. If you see here, PP3 is the line segment which is the minimum in length. Or other way we can say that PP3 is perpendicular to the line segment LM. Then we can consider that PP3 is the length of the, or I can say that PP3 is the distance of the point P from the line segment LM. Or we can say the other way, that the distance between the point P and the line segment LM is PP3. Clear? In the similar manner, now if we come to our discussion on altitudes of a triangle, if we see that we can have many line segments we can draw from the point A to the vertex, to the side BC. I repeat once more, we can draw many line segments from the point A to the side BC. So what it will be? It will be something like this. It will be 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 like this. Like this, many line segments we can draw. Out of those line segments, we will consider that line segment which is perpendicular to the line segment BC or perpendicular to the side BC. In this case, it is this one. The rest all will go. So what we can say, if we consider this point as AL, that point is L, then we can say AL is the altitude of the triangle. Okay. So now let me tell you once more. From the vertex A, if we draw a perpendicular to the opposite side B, this is the perpendicular. Then the foot of, if we name that foot of the perpendicular as L, then we can say AL is altitude. of the triangle from the vertex A to the side BC. So that means what? AL is altitude. Similarly, if we use a different color, from the point B, we can draw a perpendicular line. Okay, suppose, just a minute. we draw, this is the perpendicular line. Okay, so if we name this the foot of the perpendicular as M, then we can say BM is altitude. BM is altitude. In the similar manner, dear students, from the point from the vertex C, we can draw a perpendicular to the opposite side AB. So it should be something like this. So what we get, dear students? So we get, if we say this is N, then Cn is altitude. Sorry, let me write properly.
I could not hear what you told in the beginning. Can you repeat once more?
Oh, sure, absolutely. So what I'm saying is that from the point A, from the vertex A, if we draw a perpendicular to the opposite side BC, and if L be the foot of the perpendicular, that means this angle is a perpendicular. Then we can say AL is altitude. Now you got it? Similarly,
I'm not able to understand.
okay, sure. Let me help you. So you see that there is a vertex, that is the vertex A of this triangle, correct?
Yes, sir.
And there is a side BC, opposite side BC, correct?
Yes,
Now
sir.
what we are doing is that from that vertex A, we are drawing a perpendicular. You see that blue color line, the perpendicular. So if we draw this perpendicular, then it will intersect that side BC at a point. We name this point as L. Correct? So far correct? So far you understood? Then this length of this line segment AL, that AL line segment is known as the altitude, as I write here. Correct now? Okay. Now in the similar manner, when we consider the point vertex B, similarly from the vertex B, we can draw a perpendicular to the opposite side CA, and if M be the foot of this perpendicular, that means this angle is 90 degree. Correct? Are you getting my point? This angle is 90 degrees. Then we can say that BM is altitude. Clear, dear students? Any doubt? In the similar manner, from the vertex C, if we draw a perpendicular to the opposite side AB, then this is also a perpendicular. Then we can say Cn is altitude. Is it clear? Absolutely clear. Anyone is having any doubt to understand the altitude, dear students? Hello Ishani, you asked questions. Now is it clear?
Yes, sir.
Okay, very good. So we discussed about the altitude. So what we can say in English word, what is altitude? An altitude has one endpoint at a vertex of the triangle and the other endpoint on the line containing the opposite side. Correct? So through each vertex an altitude can be drawn. So there are three vertices. So there are three altitudes as you see in the adjoining diagram as AL, BM and CN. Now